Hi dear students, you might have come across the working construction and the principle of AC generator. So in that diagram they would have shown you a rectangular coil PQRS or ABCD, right, with slip rings, brushes and so on. But they would have mentioned that that rectangular coil PQRS is called as an armature, but it is not so. So what is meant by an armature? So an armature is a device which is used to support the coils. Not only to support the coils, but also increases the magnetic flux, so that the flux produced will be linked with each turn of the coil, and which induces EMF. Okay, let's draw the diagram and then I will show you the parts. Now, this is called as an armature. See here in this diagram, this has got some hollow parts here. So these are called slots. Only on the slots, n turns of coils would be wound. That too, the coils must be an insulated copper wire, right? So n turns of copper wires, insulated copper wires, can be wound on these slots. Okay? So just in the diagram in your book, they would have shown just a rectangular coil alone, that is one single turn, like this. So P, Q, R here, yes. So this single turn has been wound on the slots of the armature and then brought and then connected to a slot here. This slot has been connected to the armature hole, right? Now this shaft or the rod, okay, is connected to a turbine. So this turbine has coupling shaped components. Water from the reservoir or sea can be forced with a high pressure on the blades or cups of the turbine, due to which it attains a torque, and the shaft is connected to the turbine, due to which the shaft also rotates. So along with the shaft, the armature also rotates, on which n turns of coils have been wound. And you can see the armature has been laminated. So it has been made like sheets, and in between each sheet they would have placed some insulated material like mica or oil or paper like that. So in order to avoid the eddy current, we have to go for a laminated sheet of cylindrical soft iron core. So this is made up of soft iron core, because soft iron core or steel core can be easily magnetized, and it can produce more number of magnetic lines of force. Now, see, I'm going to draw a simple structure of this armature here. North pole, south pole, north pole, south pole. So this is a real structure of the AC generator. See, this is the armature on which n turns of coils have been wound, and this is a hole through which the shaft has been connected. Now these are the electromagnets which produces magnetic field. So whenever the magnetic fields or the magnetic lines of force are flowing here, whenever the shaft rotates, the armature also rotates, due to which the armature will cut the magnetic lines of force or magnetic flux, and it will increase the number of lines of force to a greater extent, so that more number of lines of force will be linked with each turn of the coil which has been wound on the slots of the armature. Now this will produce a high voltage. Here we know that for each turn we have got two slip rings which has been connected to the shaft along with the coil, right? And then we know that it has got two brushes made up of carbon, B1, B2. These brushes are used to carry the output voltage or current produced by the armature or produced by the AC generator to the external sources like a transformer. So now this transformer will step down the high voltage produced by the AC generator. So this is the actual component called armature, which supports the coil, also increases the magnetic flux linked with each turn of the coil. And this is the simple construction I have shown here. Thank you. I think that you must have understood the concept. Thank you.